This is cm2900 sample paper question 11 part 1. We've got this second order differential equation. We're asked to use Laplace transforms to find the transfer function x of s. So from the Laplace tables and notes, we know the transform of second order derivative is s squared x minus s, x of 0 minus x dot of 0, and we're given that x of 0 is 1 and x dot of 0 is 0. So we can then say that take Laplace transform of both sides. We can then say that transform of the second order derivative is just s squared x minus s times x of 0, so it's just minus s. So that takes care of the first term, and we need plus 2 times dx, transform of dx by dt, which is sx minus 1. From here, and then lastly we have 2 times transform of small x is big X. Right hand side, if looking at the tables, transform of e to the minus t is 1 upon s plus 1, and then we can take x out as a common factor in the left hand side, so we've got s squared x here, so an s squared term, 2sx here, so plus 2s, and here plus 2. So we multiply that out again, you'd have x times s squared, which is that term, the first term, x times 2s, which we can find in here, and then 2 times x, which is that term there. But we also have a minus s, which we can take across the equal sign. And from here we have 2 times minus 1, which is minus 2, crosses the equal sign to become plus 2. And combine the two terms on the right hand side. If you think of s plus 2 as being s plus 2 upon 1, we multiply the denominators, 1 times s plus 1, because s plus 1 is the denominator, and the numerator is the cross product of denominators and numerators, so s plus 2 times s plus 1 plus 1 times 1, which is 1. Multiply out this bracket, we have s times s, which is s squared s times 1 is s, plus 2 times s is plus 3s, and then we also have 2 times 1 is 2 plus 1 at the end, gives us plus 3. So therefore we divide then both sides by what's multiplying x, and then we can say that x is equal to s squared plus 3s plus 3 over s plus 1. So we're dividing both sides by this term here. They cancel, and over here we get a term introduced into the denominator, which is what we were asked to find.